Welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 5 from the October 2022 International A-Level Pure Mathematics P3 exam from Edexcel. And in this question, we got the question all about trig, identities, and equations. So part A says, show that the equation 3 cosine theta minus tan theta in brackets times cosine theta equals 2 can be written as 3 sine squared theta plus sine theta minus 1 equals 0. So we've got to start with this expression here, and we've got to rewrite it such that it looks like this. So when we look at this, the first thing I can imagine that we can do is expand the brackets, right? We've got 3 cosine theta times cosine theta. That will give us 3 times cosine squared theta. And we got minus tan theta times cosine theta, which is minus tan theta times cosine theta. And that's equal to 2. Now, the next thing I can do, as we can see that all of these terms are in terms of sine squared theta, sine theta, so on. So what I can do is I can use the identity, okay, for sine squared theta plus cosine squared theta equals 1 in order to change this cosine squared theta such that it becomes 1 minus sine squared theta. So I'm going to express it in terms of sine squared theta. So cosine squared theta is 1 minus sine squared theta if you just rearrange this. So because I want to end up with just sines in here, I can replace this cosine squared theta with 1 minus sine squared theta. Okay, that's a very important identity here that we must know. And then, in addition to that, I know the other identity that we know in P2 is that tan theta is the same as the sine of theta over the cosine of theta. So the tan of an angle gives us exactly the same ratio as a sine of that same angle divided by the cosine of that same angle, right? So I can replace the tan theta with sine theta over cosine theta, and that's multiplied by cosine theta, and then you got equals 2. So here the cosine thetas will cancel out. So now we're left with an expression which only has sines in it. You have 3 times 1, which is 3, minus 3 times sine squared theta, which is 3 sine squared theta, minus sine theta equals 2. So we've almost got what we need here. We have to just rearrange it a little bit. So what we can do is I could multiply both sides of the equation by -1 to change the signs of everything. So this becomes 3 sine squared theta plus sine theta minus 3 equals -2. Just multiply both sides by -1. And then I can add 2 to both sides. And I'm going to get exactly what we're supposed to show here. We get 3 sine squared theta plus sine theta. You add 2 to both sides. That gives you -1 equals 0. So we've now shown exactly how to get what we need from what they told us to start with. Now, one of the places where many students make errors in this, and I want to address this because a lot of students make these errors, is they think that because sine squared theta plus cosine squared theta equals 1, that entails that sine theta plus cosine theta equals 1, and that's completely wrong. That is completely wrong, right? You can't say, oh, let's square root both sides, so therefore, so what many students, they do things like they replace a cosine theta here with 1 minus sine theta. You can't. Only when it's squared. The sine of an angle all squared. Okay, this means basically, what this means is sine of an angle all squared plus the cosine of another angle all squared equals 1. Not the sine of the angle plus the cosine of the angle equals 1. No, the sine of the angle all squared. That's what sine squared theta means. The sine of the angle the whole thing squared plus the cosine of the angle squared. That's what equals 1. Right? Now some people say, but take the square root of both sides. That's not how that works either. Right? If you were to take, for example, 3 squared and 4 squared, that's going to give you 5 squared. We know that. That's a Pythagorean triple. Right? 3 squared 9 plus 4 squared 16 is the same as 5 squared 25. But does that mean that 3 plus 4 equals 5? Well, no, it doesn't. 3 plus 4 is not equal to 5. Okay, so you can't just say, let's take the square root of both sides. If you're going to take the square root of both sides, then this would become the square root of 3 squared plus 4 squared equals the square root of 5. Okay, that's true, right? But that's not true. Okay, if they're separate terms added together, you can't say the square root is just take the square of them. No, right? So there's some important points that we must realize. So don't ever replace cosine theta with 1 minus sine theta. Don't ever replace sine theta with 1 minus cosine theta. It's only if they're squared can you replace them with 1 minus the other one squared. So cosine squared theta can be replaced with 1 minus sine squared theta. And sine squared theta can be replaced with 1 minus cosine squared theta. So it's very important for us to realize that. It's a little side point there, because I notice many students do have that misconception. All right, now for part B. It says, hence, solve for x between minus pi over 2 and pi over 2, the equation 3 cosine 2x minus tan 2x brackets times cosine 2x equals 2. So if we compare this, first it says hence. Now hence means using what we just did. So we have to go back and look at what we did. And one thing you realize is this thing that we had to rearrange and what we got to solve, they look almost identical, except that instead of theta, you now have 2x. So what I'm going to do is, when I'm going to rewrite it in this form, which is in a way easy, a way like a much easier way of solving. Okay, if I rearrange it and write it in this form, it's going to make it much easier for us to solve than having it in the original form that they gave us. Then what I can do is I can say, therefore, I can just basically rewrite it in the same form, but just replace the theta with 2x. So this is the same as 3 times the sine squared of 2x plus the sine of 2x minus 1 equals 0. All right, so now I can proceed and solve this equation. Now, to make it a bit easier for us to try to solve the equation, we notice that this is like a quadratic. This is 3 times something squared plus something minus 1. Remember, sine squared of 2x is like sine 2x all squared, right? So if we say let, for any letter like, for example, u equals sine of 2x, right? That means u squared will be the sine of 2x all squared, which is the same thing as sine squared 2x. So I can say this is like 3 times u squared plus u minus 1 equals 0. Now I can try to solve this quadratic equation. The first thing we should try to do is see if we can factorize it, okay? But I think this won't factorize because we have to find two numbers that multiply to give you -3. The product has to be -3, okay, because you've got to split the middle term in this case, because you have a number here. And the sum of those two numbers that multiply to -3 has to give b plus 1. And the only way to get 3 as a product is 3 times 1, where one of them is going to be positive, one of them negative. Now, that will always give you a difference of 2, not 1, right? So there's no way I can have two numbers multiplied together to give me 3 or -3, and the sum of those numbers would be 1. So this will not factorize. We cannot factorize this. So we have a couple of options. We could use the quadratic formula, which most people will probably do, or we could use the completing the square method, right? Now, if you use a quadratic formula, that's fine. If you use completing the square, that's fine. But you must show your method. You must show that you used the quadratic formula, right? So you must say, for example, you must, if you quote the formula, that's good. So you have minus b plus or minus the square root of b squared minus 4ac all over 2a. So you must use it in the right way. So you're going to put minus, now the coefficient of x squared is 3. So a is 3. The coefficient of x is 1. In this case, it's u squared and u. All right, so the coefficient of the u is 1. And the value of c is -1. So then you replace, instead of b, 1, instead of a, 3, and instead of c, -1. And then you have your solutions from the quadratic formula. All right, so that's pretty simple to do. But what I'm going to do is I'm going to show you how to use completing the square, just to jog our memories and remind us of completing the square, which is a very important process that we learn. Okay, so just to as a revision of completing the square, I'll show you how to solve it by completing the square. To solve by completing the square, what we can do is the way I like to do it first is I like to first of all take the constant and get rid of it from the side from the left side of the equation. So I'll add 1 to both sides to get rid of it. So I'll have 3u squared plus u equals 1. And then the second thing I like to do is I like to get rid of the coefficient of the x squared in this term, the u squared term. I like to make it equal 1. All right, so I have 1 of that term squared, so 1u squared. So I'm going to divide the whole of the equation by 3 to make this into 1u squared. So this will be u squared plus, and this is going to be 1/3 u. U divided by 3 is 1/3 u equals 1 over 3, which is 1/3. Right, now we are ready to complete the square. Now we're going to start completing the square. So I'll just make some space here. All right. Now I'm going to put my bracket. It's going to be squared. Right, completing the square. The u, you have a u and you'll have a plus. And then what you have to do is you have to write a half of the coefficient of this term. Now a half of a third is 1 over 6. And you only write the coefficient, you don't write the u there. Right? That, if I expand it, will give me u squared plus a third u, but then it will also give me plus 1 over 36. If I expanded this, I'll have u squared plus 2 times u times 1 over 6, which is 1 over 3u. And then I'll have plus 1 over 36 squared. 1 over 6 squared, which is 1 over 36. I don't want the 1 over 36. There's no 1 over 36 here, so I'm going to take that part away. And now I have completed the square for this expression. If I expand this, I'll get exactly that. Right? And we know that this whole thing is equal to 1/3. So now what I can do is I can say u plus 1 over 6 all squared. If I add 1 over 36 to both sides, so I'm going to get basically the 1 over 3 here is like 12 over 36. I'm just getting it ready to add to this so that I have like, the same denominator. Plus 1 over 36, I have to add it to both sides. Add 1 over 36 to both sides. Now that will give me u plus 1 over 6 squared is equal to 13 over 36. All right, so I'll just do it like this so that we get more space. So u plus 1 over 6 is equal to plus or minus the square root of 13 over 6. Take the square root of 13. Okay, root 13. It's not a perfect square. Positive and negative, and the square root of 36 is 6. So this will give us, now if we continue, we'll say u is equal to, if you subtract from both sides, okay, 1 over 6, you'll have minus 1 plus or minus the square root of 13 all over 6. Okay, that's what you'll have there. Right? So minus 1, so you subtract 1 from both sides, plus or minus root 13 over 6. So that's your value of u. So now what we can say is we called u2 sine 2x. So now what we can say is the sine of 2x can either be minus 1 plus root 13 over 6, or the sine of 2x can be minus 1 minus root 13 all over 6. Those are the two solutions now, all right? So now we can solve for x. Now we can solve for x. So to solve for x, first of all, we have to realize our limits, right? We have to solve for x between minus pi over 2 and pi over 2. So we got our x values are between minus pi over 2 and pi over 2. So we have between minus pi over 2 and pi over 2. It had the equal signs as well, didn't it? Yes, it did. Okay. Now, we want to solve for 2x. Well, we have 2x here, and that says x in the limits, right? Of course, in the end, our answer is going to be x. But what we have to do is, to make sure that we don't lose any solutions, we have to modify this so that this says 2x as well in the middle. So if I make this 2x, I have to multiply by 2. So I multiply both of these ends by 2. So 2 times pi over 2 is pi. And 2 times minus pi over 2 is minus pi. That means I have to catch all the solutions between minus pi and pi for these two equations. So how do I find the solutions? Well, the first solution I find, let's start with this one, is when I write 2x equals the inverse sine of minus 1 plus root 13 over 6. Okay, so that's the first thing I need to do. So I'm going to use my calculator. Now, we can see that the limits are given in terms of pi, which means in radians. Okay, in radians. Now, this calculator is in radian mode. In case you didn't know how to do it, shift, menu, angle unit, radians. So this calculator is now in radian mode, right? So what we're going to do now is we're going to put this into our calculator. So inverse sine minus 1 plus root 13 all over 6. And that gives us our first solution, which is 0.44921. So we have 2x equals 0.44921. Now that's one solution. Okay, that's one solution. Now what I'm going to do down here, just to make it clear, is I'm going to draw a little sketch so that we can understand exactly what we're doing in terms of the sine curve. The sine curve between minus pi and plus pi, okay, minus 180 and plus 180 looks something like this, right? Oops, the other way around. What am I talking about? Starting too early. So it's going to be like this. So it's going to be like this. That's the sine curve between minus pi and pi, right? So minus pi means, pi there, that means 180 degrees. So that's minus pi here, and that's pi here. Now, what we've just found here is we found when the sine curve is equal to this value over here, it's a positive value because root 13 is more than 1, so it's going to be a positive value. So we've basically just found a solution over here. That's what we just found. This is like the 0.44921. That's what we just found. Okay, we found that solution. All right? Okay, we can think of it like that. Now, there's another solution over here which shares the same sign ratio. So I want to find what that is. Okay, so I know that for the sine curve, the main angle is found by using the calculator, inverse sine of whatever the ratio is. And the other main angle is always 180 or pi minus this angle. So we're going to do pi minus 0.44921. And that will give us, so we take our answer. Okay, take our answer and we do pi minus the answer. And that gives us 2.69237. 2.69237. 2.69237. That's the other angle. That's the other main angle here. So these are the two angles we just found. There's no other angle between minus pi and pi for this answer over here. So those are our two solutions. And then to find the answers, we divide them by 2. All right, so I'm going to take this answer. I'm going to divide it by 2. That gives me 1.3461. So 1.3461 dot, dot, dot. I'll leave it like that for now. And this answer, I'm going to take the answer and also divide it by 2 because we want to find x not 2x. So I'll go back to here and I'll take this answer and divide it by 2. And that gives me 0.22460. 0.22460, whatever, it continues. All right, in the end, I'm going to round it to 3SF because they didn't mention anything, and this is angles in radians, which you should round to 3SF if the answer is not exact. Now, for the other section here, we have sine 2x equals minus 1 minus root 13. So therefore, we can say that 2x is equal to inverse sine of minus 1 minus root 13 over 6. Okay, so we can say 2x is equal to, now this is going to be, we can see it's going to be a negative value, right? The ratio is going to be negative. So we're going to get this line going on the negative side, right? So we're going to the first answer we're going to get is this answer over here. That's what the calculator is going to give us. So when I put this in my calculator, right, so I'll just go back to here and replace this with a minus sign. Oops, a minus sign. Minus 1 minus root 13 over 6, inverse sine, radian mode. That gives us negative 0.8750. So negative 0.87507 continues like that. That's this solution over here. That's this solution over here. Okay, that's what we just found. Now, we can see there's another solution over here. How do we find this other solution? Well, the simplest way, where you don't have to think about it too much, is by doing the following. It's by thinking about this curve if you continue it. As I said, to find the other main solution, you always do pi minus your answer. So I'm going to do pi minus negative 0.87507. All right, so I'm going to take this answer and I will do pi minus this answer. So pi minus the answer. Now that's going to give me an answer which is outside of my range, which is 4. Okay, this is going to be 4.0. 4.01666. 4.1010666 continues on. Now that is basically over here somewhere, which is outside of our range. My pi is 3.142, and this is minus 3.142. This is 4 point something, outside of my range. However, I know that this angle over here is separated from that angle by 2 pi, because the sine curve repeats every 2 pi. So the curve is dropping here. The next time it drops in the same place here is going to be 2 pi away. So our answer is going to be 2 pi minus 4.01666. So we take this angle here and we do 2 pi minus this answer, and that will give us what we're looking for, 2.26665. Okay, so actually, no, what am I doing? It's not 2 pi minus this angle. Stop what I said there. It's this angle minus 2 pi. Okay, it's this angle. So it's 4.01666 minus 2 pi. Other way around. So this angle, you've got to go back 2 pi. Right? You've got to take away 2 pi from it. Excuse me for that, right? You're going to take 2 pi away from it. So actually, it's this angle here. Okay, so we got this answer, and then we did pi minus this answer, right, which gave us this, and then we've got to go back 2 pi. So we've got to take away 2 pi from this angle. Okay, and that gives us the answer that we're looking for, which is negative 2.2665. Negative 2.2665 continues on. So our solutions that we need from this are this solution and this solution here. So I can say that means x is equal to this number divided by 2 and this number divided by 2. So I'll take the number here and I'll divide it by 2, and it gives me negative 1.133, negative 1.1332. Negative 1.1332 continues on. And this answer here, we divide it by 2. So let's go back to find where this answer is. Okay, that's this answer. We divide that by 2, and it gives us negative 0.4375. Negative 0.4375. So those are our solutions. We have 4 solutions. So I'm going to write them all down over here, and I'm going to write them in order of size. You don't have to do that. So I'll put the lowest first, which is this one, and I'll write them to 3SF. Minus 1.13, and then negative 0.438 to 3SF, and then 0.225, and then 1.35. Right, so I've rounded them all to 3 significant figures, and that's a very long question, right? But it's very important, and I think this was, the examiner's report says, was the least well answered question, especially part B on this paper. Many people lost solutions. They didn't find all the solutions, especially this solution here, this last negative one. You know, so it's something that you have to be very well versed in. This is all about radians and the numbers. The angles were not like, in terms of pi, they were like these decimals. And so a lot of students got kind of confused, but that's something that you have to really work on if you have problems with trigonometry. And making a little diagram of what you're doing and understanding what the curves look like and how to find the main angles and the other angles from them is very important. So for the sine curve, you use your calculator to find the main angle. You do pi minus that or 180 minus that in degrees to find the other main angle, like we did here. In this case, we found the angle from the calculator, which was this. And pi minus that angle gave us that angle, which is out of our range. But then all the other angles that you can find are separated from these by 360. So this angle, take away 360, gave us the other angle that we were looking for. Right? For the cosine curve, it's slightly different. You've got the main angle from the calculator, of course. Then you have 360 or 2 pi minus the angle gives you the main angle. And then the rest, they separate by 2 pi's. For the tangent curve, it's a little bit easier. It's just one main angle you get. And all the other angles are just separated from that by 180. So you add 182, take away 180 from, the angle, and you end up with other angles in the range. So that's the answer to this question. Question number 5. I hope that was clear for you all. Thank you for watching. Other questions from this particular paper, October 2022 P2, that can be found in the playlist in this section over here. Other questions from trig identities and equations from P2, I've collected in the playlist over here. You can subscribe to the channel by clicking on the link in the middle. Thank you for watching and see you soon.